Look, folks, we're given ideas, concepts in math, geometry, whatever you want to call it, to practice our deductive reasoning skills. So, yeah, we got to understand the concept in order to practice. But, each little individual concept all by itself is not the most important concept in the world. We're trying to learn the little concept and then eventually build on it and attach other ideas to it and go with more significant ideas. So sometimes the idea seems like, really? Is that all there is to it? I hope today feels a little bit like that. Like this is kind of easy. Hey, look, let's start with this. When you look at the window in our classroom, toward the window, there are posters on the wall. And let me show you, they're like homemade posters, they're not fancy. There's three numbers on them. So one of them up there is 5, 12, 13. It's on the left side of the window. So 5, 12, 13. We talked a little bit about this. These are three side lengths in a right triangle. So I have a little tool down here like this guy right here. And if I click on it again, I can make certain particular triangles. Like this one's an equilateral triangle. This one's a right triangle, right? I don't know. Maybe this one's an isosceles. I can't remember. I'm not worried about that right now. But I made a few before, you saw this document. And here is a right triangle. So it could be, I'm not sure it is, but it could be a 5, 12, 13 because each one of those posters represents side lengths in a right triangle. Those work in the Pythagorean theorem. 5 squared plus 12 squared equals 13 squared. Okay, let me show you another poster over there on the wall. And by the way, the Pythagorean theorem is not our main focus today. So don't think, oh no, I've never seen that before. Don't worry too much about it. If you have, great. 12, 35, 37. So 12, 35, 37. Those are three more sides in a right triangle. I've not really seen those in a lot of homework problems. That's the reason I made those posters, is that some of these come up a lot. 5, 12, 13 comes up a lot. 12, 35, 37 is not one that comes up a lot. How do I know those are three sides of a triangle? Because they're on that poster and I've messed with Pythagorean theorem before enough. And we're going to learn a little bit today that would tell me these side lengths would make a triangle. They're definitely going to make a triangle. You might say, why would side lengths not make a triangle? We'll look at that here in just a second. So if this was an equilateral triangle, it would have to have some tick marks on it to tell you for sure that it's equilateral. They kind of looked like they were equal to each other, but that's something we've talked about. You can't assume something's equal. Like one segment's equal to another segment just by the way it looks. You've got to be told that they're equal to each other. Okay. So it could be side lengths of like 7. I like the number 7. 7, 7. It sounds nice, doesn't it? 7. So we got three side lengths of 7. All right. Hey, I want you to open up a GeoGebra sketch. The sketch is on our classroom resources today. So when you look at today's assignment, it's going to be right there. Okay, so you're going to open that guy up, and then this is what we're doing in class. So if you were here today, you're like, yeah, we did that. Of course we did. So anyways, I got to get over to my sketch. Oh shoot, here it is. All right. So what I'm going to ask people to do in class is, click on point F and move it. Okay, so you can swing that around. You can see the side length doesn't change. However, like visually to me, it kind of looks like almost like when it goes vertical, it does look a little bit longer. I think that's like an optical illusion, or I don't know, maybe it has something to do with the aspect of our screen, being a rectangle. Maybe it does appear like it's changing length, but it's not. It's 2.5, right? And then 3, here's 3 over here. It never changes. Could you make these three side lengths into a triangle? Like you can move this one. I know it never changes this length, but so move however you want and make a triangle if you can. Okay, so our like kind of debate today is going to be, can you make this into a triangle? Ooh, that's a little tough. So it would be like that, something like that, right? So it definitely could be. Having a hard time getting the computer to get that point right there. So you get the idea. That would make a triangle for sure, right? Okay, now let's look at the next one. So if I grab this guy and I move it around, oh, wait a minute. That should not be changing length. What the heck? Oh, no. I'm glad I'm practicing this right now because I got to fix that. That should be staying the same length the entire time. And let's see if this one does. Oh, yeah, it does, right? How about this one? Is this one messed up? No. Oh, no. Oh, no. That can't happen. Oh, shoot. Well, I want you to pretend. Oops. I want you to pretend like this one always stays too long. It kind of is. It's getting bigger for some reason over there. Would this ever make a triangle right here? I know it's getting longer. Dang it. Shoot. No, this one wouldn't make a triangle because see, look, these two sides, they flop down on the bottom side. So what is the requirement? Well, I want you to take the two smaller sides up here, 3 and 2.6. Add them together and you get 5.6. 5.6, those two added together is bigger than 5. So if they're not big enough, then they would just fall flat down on the third side, like these two down here. Okay, they just fall flat. It's like making a tent, right? If your sides of your tent aren't long enough, if the two sides of the tent aren't long enough, they're not going to meet over the top of the base. They're just going to fall flat onto the base. You're going to be sleeping with material right on your face, right? So these two side lengths are not long enough right here. They don't add up to be bigger than 5. Okay, so let's try a homework problem right now. Then I'm going to ask people to put some notes down. This one up here is yes, it would make a triangle. So yes, and it goes like this. It would come over here and they both would meet at a certain spot, and this would be 2.5. And then this would be 3 long over here. And you can see 3 plus 2.5, 3 plus 2.5 is bigger than 5, the third side. So this is where the longest side goes. We're testing to see if the two shorter sides, the shorter ones, okay, added together, if they're bigger than the longer side, right? So yeah, 5.5 is definitely bigger than 5. If we try that down here, this is a no, it didn't make a triangle. Right now with the 2 and the 1.5, I'm going to fix it before class. So I'm going to use 1.5 plus 2. I'm not going to let it get larger like it did. And then that's got to be bigger than 5 if it's going to make a triangle. But 3.5 is not bigger than, you can put a like slash through it. I don't like the fact that it's black slash. It looks kind of weird. So I'm going to go to red. So put like a red slash through it. And so that 3.5 is not bigger than 5. So no triangle. So ... no triangle. All right. So let's try a homework problem, see if we got this down. Problem number 1. Here are the two shorter sides, 9 and 12. Do they add up to be bigger than 18? Now, if you're good at arithmetic in your head, you just said 9 plus 12 is 21, right? So 9 plus 12 equals 21. And then we got 18. So 21 is definitely bigger than 18. So the answer is yes. See, the two shorter sides have to add up to be bigger than the 18. Okay. And they do, right? They add up to be 21. So how do you do this kind of problem when it says find the range for the measures of the third side of the triangle when the measures of the other two sides are 18 and 23? So let's for a second pretend like it goes like this: 18, 23, and then the longest side. Because I think all the homework problems at the beginning put the two shorter sides first, and then they put the longer side third, I think. So what if these were the two shorter sides and we're looking for what's the biggest the third side could be? Well, 18 and 23. So if I go 18 plus 23, that gives me 41. Okay. So this third side cannot be 41. It's got to be less than 41, right? Like it could be 40.9999. It could be 40.5. It could be 40. It could be 39. It could be 39.875, right? It just cannot be 41. So I'll put a number there, but it's anything less than this number. So let me put down 40.99999, right? Because the two smaller ones have to add up to be greater than the third side. So here's the thing we're going to do. We're going to use a less than symbol. Let me zoom in on that. Might be kind of small on the screen for you. So we're going to use a less than symbol right there, and we're going to put the number 41 right in here. So let me switch back to black, and I'm going to put 41 right in there because we're saying the third side. That's what n represents. N represents the third side of the triangle. Third side. We know two of the sides. What's the third side potentially? It can't be bigger than 41. All right, because 18 and 23 equal 41, and 18 and 23, if they're the smaller sides, have to be, bigger than 41. Or it has to be bigger than the third side. So that's why it can't be The third side can't be 41. Now, let's say 23 is the largest side. Let's say it goes like something, comma, 18, comma, 23. Okay, now 23 is the largest. Okay, well, if these are the two smaller ones, smaller, I should say, smaller than the third side, then this side right here, let's see, would have to be bigger than 5, wouldn't it? Like if it was exactly 5, no can do, because 5 and 18 make 23. We want 5 and 18 to be bigger than 23. See, 5 plus 18 needs to be bigger than the third side. The largest side, I should say, third side. Okay. So 5 plus 18 is not bigger than 23. It's equal to 23. So we need this side to be bigger than 5. That's why they're using that little greater than symbol right there, right? It would have to be like 5.1 or 5.0001 or something like that, right? So it's between 5 and 41. So in a nutshell, here's what you do. You take 18 and 23, take 18 and 23, and you add them together, and you get 41. That's as big as it could ever be. It actually needs to be smaller than that, right? You take 23 minus 18. If you subtract the other way, you get a negative number, and you get 5. That's the smallest. It's actually got to be bigger than that side. The third side has to be bigger than that. So it's between 5 and 41, the third side. All right. I hope I made those two types of problems clear. Those are the two types of problems we're going to deal with in homework today. Thanks for watching my video.